some of the videos weren't working, and plus we really haven't talked about it in class necessarily together yet. But let's just start with sequences in general. Anytime we have a group of numbers and they have a pattern, that's a sequence. We're going to focus mainly on arithmetic and geometric sequences. Remember, arithmetic were the ones where we have repeated addition. Now, really, repeated subtraction counts as well, but we're going to think about subtraction as adding negative numbers. Okay, so we're always going to think about addition over and over again. What does a graph of an arithmetic sequence look like? Yeah, it's going to be in a line. Yeah, it's going to be linear. And that's nice because if it's linear, we know it has to fit a linear equation. So we got to think about things like slope. We got to think about the initial term or the y-intercept. Geometrics are when we have repeated multiplication. Now again, division fits in that as well, but instead of saying I'm going to keep dividing by 5, I'm going to say I'm multiplying by 1/5 over and over again. Geometrics aren't linear, they're actually fitting more of an exponential situation. And so we'll look at the equation of that here in a second. Okay? Now that doesn't mean these are the only two types of sequences, but we're going to group all the other ones into kind of just the other category or the neither category. But we're going to focus mainly on arithmetic geometry. So on the warm-up here, the first problem where you have the sequence of -4, -6, and so on. Before you can come up with an equation, you got to know, is it arithmetic or geometric? Well, this one we had that repeated process of, you may have thought about subtracting 2, but again, I'm thinking about adding the -2, same idea, which means we're talking about a linear situation. So if I'm going to do an explicit equation, an explicit equation is no different than when we did any other linear equation. So I need the slope or the growth or the pattern to start with. Well, that was -2. So I might say -2n for that. But then I need the y-intercept or the initial value or the 0 term. Well, this is the first term, this is the second term, and so on. So to go back to the 0 term, I've got to think in reverse. So if I think in reverse, what's the 0 term going to have for a value? -2. And that's why we throw the -2 there. So this would be the explicit equation. The nice thing about the explicit equation, if I said, okay, find the 100th term in that sequence, well, all I'd have to do is plug 100 in for n, and you can find the 100th term. The recursive equation, though, is one where we want to try to figure out how would I find the next number in my pattern or in my sequence. So a lot of times, or the way the book's going to write it at least, is they're going to say t of n plus 1. So in other words, we're saying, here's how you find the next term. You're going to take the term you're on right now, so t of n, and then you're going to do some sort of pattern to it. Well, the pattern here you said was subtracting 2 or adding a -2. So they're saying in order to get the next term, take the one you're on now and subtract 2. Well, if they didn't give you these numbers before that, this information doesn't tell you a whole lot. It tells you the pattern, but it didn't tell you any of the values. So you have to add to that another equation that tells them at least one value. Most of the time we do the first one. So the first value is -4. So even though they're asking for a recursive equation, you're really writing 2 equations. You're writing the pattern equation, and then you're writing at least one value. I could have picked any value I wanted to up here. Usually you'll see the first one. So this would be a recursive. Advantages to recursive is they're easy to write once you get the notation down, because you're just writing the pattern. What's the disadvantage of the recursive equation? Well,
You can't find a set unless you have the one before.
yeah, exactly. If I ask you for the 100th term, well, you got to know 99 to know the 100. You got to know 98 to know 99, and so on. Versus if I have an explicit one that asks for the 100th, you just plug it in, you know what the answer is. So sometimes explicit's a little more, I guess, useful. So. All right, let's look at the third one because this is the geometric situation. On this one, hopefully you figured out that you're multiplying by a third each time. So when I write the equation for the explicit formula, I'm going to think in terms of an exponential equation. Well, an exponential equation, part of it is that pattern. In this case, it was 1/3. If I keep multiplying over and over and over by the same number, I know I'm doing that a certain number of times, so I have an exponent. This is still the 0 term. It's still going to be our initial value. Well, the original one had 81 for the first term, and then 27, and so on. So we said that's multiplying by a third in that direction, or dividing by 3. So if I backtrack to the 0 term, well, that means I got to multiply by 3 to do that. So when I multiply by 3, I get my 0 term, or initial value. So that would be our explicit equation, 243, because that's a 0 term, times a third to the n power. And again, if I ask you for the 50th term, you just plug 50 in front. The recursive, well, that's based on a pattern. So in order to find the next term, I need the one I'm on now times the pattern of 1/3, or you can say 1/3 too. And then I need something to work with. Doesn't matter which one, the easiest one is the first one. And that would be my recursive. So recursives are something you're probably not as familiar with, but I think once you get those down, they're actually a little bit easier in some way. Well, something else we'll have to do is like 4 and 5, going back and forth. So if they give you the explicit, you got to find the recursive. Or I guess on 4, you were given the recursive, you had to find the explicit. But we got to go one way or the other sometimes. So if I look at that recursive equation, again, the first thing I ask myself is, what am I dealing with? Arithmetic, geometric. Well, according to this pattern here, what kind of sequence are we looking at? Geometric. So that means when I write my explicit, it needs to be in that exponential form. Well, the pattern was multiplying by 4, so I have 4 to the n power. If the first term is 24, what would I get when I backtracked to the 0 term? Keep in mind I multiply by 4 as I increase. So that's your explicit form. The next one looks like I already. The next one, they gave us this explicit formula. G of n is equal to negative 3n plus 1. Arithmetic, geometric. Arithmetic. This is my pattern. This is my 0 term. So when I do my recursive, in order to find the next term, I take the one I'm on right now. According to my pattern, I subtract 3. I need to give them a value to work with. I can use the one they gave me, which was the 0 term if I wanted to. So I could make it as simple as that. So use 0 plus 1. If I decided to use the first term, what's the first term on this list? -2. I take the 1 minus 3. So this doesn't matter as long as it's part of our sequence. It can be whatever you want. That's the big part of Appendix A, is being able to decide if it's arithmetic or geometric. and then decide how to write an explicit or recursive equation. I mentioned the other day, but we're not doing everything in Appendix A, we're not doing everything in Appendix B, but that's the main idea of Appendix A. All right, from the homework, I didn't hear too many questions, but I do want you to look, this is number 98. I want you to discuss, if I can get it here, Part D with your group to see if you figured out how to do Part D. This was number 98. They ask you to write a recursive and an explicit equation for that. Again, share any strategies that you used on figuring out those two things. Explicit. Question still remains the same at the beginning. After the arithmetic. All right, again, the first question is always, is it arithmetic, is it geometric? This one was slightly different because of the gaps, but you can still look for the same idea. Did we add the same amount? Did we multiply the same amount? Well, we didn't add the same amount because we went from here to here and here to here. Did we multiply by the same amount to get from here to here and then here to here? Yeah. If I took 72 divided by that 50, I get 1.44. Now, that's not my pattern quite yet, but it's going to help me find my pattern. Because I know for every two terms, I multiply by 1.44. I want to know though, what did I multiply by on each term? Well, we're really dealing with a type of exponential, and exponentials we'll write in this form. So what I'm really looking for is this b value. So what I've done is I've taken 50 and I've multiplied by some b value 2 times. Or in other words, b times b, or b squared, was equal to a total of 1.44. So if I want to figure out the pattern, what am I going to have to do? Which was 1.2, you're right. But our b value is 1.2 because we had the square root. I heard you say earlier you had the square root. Now I got my pattern. Do I have enough yet to figure out my equation? I got this part of it. No, I still got to backtrack and figure out what the zero term was. Okay, so Rachel, let me get the first thing. I said Rachel, sorry. Not Rachel. You is what I'm talking about, but I can't remember. I lost your name. I was doing pretty well on names. So. Elizabeth, sorry.
Well, I looked at the fraction.
That's fine.
I got 125.
How did you get there? You remember.
Well, since I know what B was, I just
Okay. So you divide it by 1.2 because we're multiplying that. All right, so you can leave it that way. If you did a decimal, it was a repeating decimal, but either way, it was in constant. Right, our question. All right, now we can do the recursive pretty quickly because we know the pattern. So we know it's t to the n. We know we multiply by 1.2. I can pick any value in the table. I'm going to use one that was already there. I'm going to say t1. All right, so we'll keep working on those type of things, but that's essentially, like I said, Appendix A. Well, today we're going to start looking at some things with Appendix B. And so here's what I'd like you to do with your group members to start. Okay.